everyone, welcome to part 10 of my video series on statistical significance testing. So in this video, we are going to talk about permutation testing, also known as randomization testing, which is probably my favorite test of all the tests. I will show you why in a second. So let's dive in. So this is one of the most generalized testing methods ever. That's point number one. Point number two is you can test whether an observed effect is significant just through simulation, and it can be any observed effect. I will show you that using 3 examples. There is no assumption involved of any particular data distribution, so it's applicable to any distribution. So we are going to discuss 3 real-life scenarios and use cases of permutation testing. Number 1 is comparison between 2 groups of observed values. Number 2 is correlation analysis between 2 variables. And number 3 is performance comparison between 2 methods. In the age of machine learning, this is actually very important as well. The first case. So what is the problem? Let's assume that the problem is, are Bangladeshi men significantly taller than Bangladeshi women? That is the question. So in order to answer that question, let's assume 2 hypotheses. The null hypothesis is BD men and women have similar heights, and the alternate hypothesis is BD men are significantly taller than BD women. So this is the data we collected. We collected data of 10 men and 10 women from BD. Then we calculate their mean, and we get their difference. The difference is 12.1. This is basically an observed difference. What we can do now is we can pull all these 20 heights together. So 10 plus 10, 20. Now what we are going to do is we are going to randomly assign the gender label to this height so that there are 10 men and 10 women. So understand that 170 is a height of man, 168 is a height of man, and so on and so forth. But here those labels are sort of swapped. For example, let's assume that green labels are actually men and red ones are female. So 168 was originally labeled as men, but it is now labeled as a female or a woman. So we swap those labels and we randomly assign labels. After doing that, we can get the mean man and mean women height for this particular case, and we can store the difference, right? So original difference was 12.1. Maybe this difference is, I don't know, maybe 3.2 or something like that, whatever. So we can repeat this entire process of putting together randomly assigning labels maybe 10,000 times and calculate 10,000 difference values. Now what we are going to see is we are going to actually try to see how many of these differences are actually greater than our observed 12.1. Maybe it's only 3 times. Maybe there are only 3 times where we get a difference of greater than 12.1. So now I think you know what we are going to do. We are going to get the p-value in this way, p-value equal to 3 by 10,000, which is 0.0003, extremely small, so we can reject the null hypothesis. That means BD men are actually taller than BD women. So we have proven this. So this is one example. The next example can be a very different type of example where we try to get the correlation between x and y variables. So the question is, are variables x and y significantly positively correlated? So in order to answer this question, first of all, let's get our hypothesis. So no correlation between x and y is a null hypothesis, and x and y significantly positively correlated is our alternate hypothesis. So this is basically our data, x and y. So 2, 3 is a pair, 4, 5 is a pair, 5, 7 is a pair. So there are 10 pairs. So we can easily calculate the Pearson correlation coefficient. And I'm not going to show the formula of Pearson correlation coefficient computation because that's not the core purpose of the video. Maybe this correlation appeared to be 0.98, which is very, very large. Now what we are going to do is we are going to randomly shuffle y. We are going to randomly shuffle these y values and keep x unchanged to make new random pairs. For example, initially this was the pair 2, 3. After shuffling, the pair became 2, 11. So 2 and 11. Initially 4, 5 was the pair. Now the pair is 4, 3. 3 is from here after random shuffling of y. So we are going to get all these 10 pairs to all these new 10 pairs. We are going to get the Pearson correlation coefficient of these 10 pairs. Suppose that is 0.13. So we can do this 10,000 times. We can shuffle the label, calculate the Pearson correlation coefficient 10,000 times. And after doing that, we can actually try to see how many times were the computed correlation bigger than 0.98, maybe only 10 times, maybe. In that case, our p-value will be 10 out of 10,000, which is 0.001, which is again very small. We can reject the null hypothesis, and so x and y are significantly positively correlated. That is problem number 2. Now for the last problem, it is also again very different from the previous two problems. Does classification model A perform significantly better than classification model B? Okay, fine. So classification, we all know that we have some, maybe we're trying to predict cat and dog. So there's an image, whether that image is an image of a cat or an image of a dog. So we are trying to predict that. That can be a classification model, right? Okay, so the first hypothesis, null hypothesis, is the two models have similar performance. The alternate one is model A performs significantly better than model B. Okay, so this is our data. So we have 10 samples in total. These are the two labels. Label 1 means positive and label 0 means negative. Maybe 1 is cat and 0 is dog. And these are model A probability scores and these are model B probability scores. Now from this table, we can actually get the AUC score. So if you don't know about AUC score, don't worry. AUC score is a performance metric for classification performance of a model. So suppose model A AUC score is 0.9, model B AUC score is 0.7 from these probabilities. And the observed difference thus is 0.9 minus 0.7 equal to 0.2. So now let's do our testing. For each of these 10 samples, we can randomly choose to do one of two things. Number one, swap model A and model B predictions. So swap these two predictions or just keep everything as it is. So let me show you what I mean by that here. So these are our samples. These are our true labels. We keep them as they are. For sample 2, we are swapping. You can see that here 0.2 and 0.3, but here there is 0.3 and 0.2. For again, sample 4, we are swapping. We can see here 0.7, 0.6, but here 0.6, 0.7. But for the ones which do not have the red circle, we do not do anything. We just keep them as it is. Okay, fine. So after doing this random swapping, we can again get the AUC score and we can get the difference and store. We can repeat this 10,000 times and get 10,000 AUC differences. And I think you know what to do next. I'm not going to tell you this again. Just imagine what to do. Okay. So this is all about permutation randomization test, extremely important test and extremely cool. So if you like the video, feel free to subscribe and share. And if you find the video useful, you can donate to our channel. There's a link in the description. Thank you very much.